All right, in this lesson, we're going to talk about probability of compound events. So that means one event and then another event. So a couple things we have to do is just take a look at the word and versus or. So think about if you needed to, pick an ace out of a deck of cards and roll a 3. That'd be pretty hard to do because it's both. If it was pick an ace or roll a 3, rolling a 3, you have a better chance of that than picking an ace, but you're starting to get the idea that and is going to be very difficult to have happen all the time, even if they're independent events. And or, they're typically, depending on the situation, they're going to make your probability a little bit easier. So that's what we're looking at. So that means we're going to have the first one and we're going to multiply. Anytime it's and, we have to multiply. So you can imagine probability of rolling that 3 and probability of rolling a 6 in your next roll. So that's 1/6 and 1/6. So your chances of 1/6 turn into 1/36, just to give you an idea. Whereas if it were or, what we're going to do later on, probably rolling a 3 plus probably rolling a 6, right? So that's 1/6 plus 1/6. So you end up with 2/6 or 1/3 of the time. So or is definitely a better vocab thing to work with. All right. You roll 2 6-sided dice. We probably roll oh my goodness. Oh my goodness. You roll a 5. So probability of getting a 5, that's 1/6. And then probability of getting a 3, that's 1/6. So that's, if I could multiply, that'd be good. 1/36. Okay. Let's probably roll an even on each. So probability of getting an even, you guys know this, is 1/2, right? It's 3 out of the 6. And we get that even again. So that's 1/2. So probability of this happening back to back is only 1/4. Okay, so we went from 1/2 to 1/4. So we start to get the idea that and or and then, those things become pretty difficult. So then implies and then before we even get that far. Bag contains 10 marbles, right? So we have 10. 2 marbles are pulled one at a time with replacement. Super important. So that means whatever I do, I'm going to multiply it by another something out of 10. So blue was 5. And then we want red, which was 3. Okay, so I'm typically going to reduce these first. This is 1/2 and then 3/10. So I get 3/20. 3/20. And orange. So orange was only 2 of them. Okay, and the red, we put it back, so it's still out of 10. The red was 3. All right, I'm still going to reduce over here. 1/5 times 3/10. If you want to do it in the end, you totally can. 3/50. Okay, that means 3 times we're successful and 47 times we are not. Right, so that's, remember that from odds as well. All right, so the only thing that happens with our dependent events is if we didn't put that marble back, which is I think what we're going to deal with here in just a second, if I remember correctly, is these would have went from 10 and then these would have been 9. Okay, so we have to be careful if we pick the thing that we wanted, so we have to lower that number as well. But we're still working with then, which means and then, so you can see the multiplication happening here. So jar contains, what do we get? 22. We get 22 marbles. And without replacement this time, super important. So that means the second time I pull something, it's only going to be out of 21. So we want green. Green was 5. And then red. So I'm even going to read it that way. And then, all right, so here's where you want to start to reduce anywhere you can. So I know 10 and 22 are both even. So I'm going to make this 5 and 11. So that'll give me 25 in the numerator, and 11 times 21, that'll become 231. A blue and then a green. So you can see these are pretty difficult things to happen. So we're starting all over each time we do this. So I'm going to go straight to 22 and 21 so I don't forget because it was a replacement. And then, okay, blue was 7 and green was 5. Okay, so 7 and 21. You guys reduce right here. So that's a little bit nicer to work with. So 5 over 66. A red and then a red. Okay. So 22 and then 21. How many red were there? Here it is, 10. Now here's where you have to remember we've reduced the denominator because we pulled a marble. That marble happened to be red, so I also have to reduce the numerator anytime we double up on the same marble color or card or whatever we're pulling for any of those things. Okay, because these are dependent events now. We're going to reduce all over the place here. What do we get? We get 10, so make it 5/11ths here, both by 3 here, so 3/7ths there. So what could have been a pretty humongous problem had another, 231 in the denominator is going to work its way down to 77 there, and 15, if I can read my handwriting perfectly there. Good stuff. All right, blue and blue, so here's there's no trick. Blue and blue, blue is 7, and then blue is 6, and we have to multiply those. Okay, so I'm still going to go with a larger reduction here, so 1/3 there, by 2 here, so I get 3 here and 11 there. And look at that, I got a 3/3 over here again, so it turns into 1/11th. So even though we had a bunch of stuff going on, we could really reduce this thing down. Now, if I want to compare any of these, obviously I'm going to turn them all into decimals because I don't want to turn everything into fractions with like denominators. That's really of a pain to do all of those things. But we can gather that 1/11th is, we could compare these pretty easy, right? There'd be 6 out of 66. So those are better. We could compare it to the 77. We might have trouble with this one over here. But if we do see the 11 here, I'm getting on a tangent, but if you see the 11 here, so this would be 21 out of 231. So not the best odds. And again, to compare them, we probably want to use decimals. Otherwise, we really have to think about our fractions here. All right, a red and a blue die are rolled. What's the probability of the red being an odd number and the blue being greater than 4? All right, so probability of an odd, and this one is on the red. That one's not bad. That's 1/2, right? And probability of being greater than 4. Okay, so that's going to be just 5 and 6. So you go 2, 6. Let's go 1/3 right away. And we're multiplying that. We needed both of these things to happen. So we're going to be at 1/6 for the entire thing. Okay, 1/2, 1/3. All right, box of chocolates contains 10 milk chocolate, 6 dark chocolate, 4 white chocolates. So that's 20 altogether. If you select at random, what's the probability that you eat a milk chocolate followed by a white chocolate? Okay, milk chocolate, there were 10 of you. So probability of a milk chocolate, MC. All right, now you ate that one, right? So that means just in the reading, there has to be 19 when you go to follow it up with a white chocolate, which was 4. But they were different. So I'm not going to lower the 4 to 3. It would only be if I did milk chocolate and then another milk chocolate. All right, anything to reduce here? I sure hope so, right? 10 out of 20 is 1/2. I'm going to reduce that again with this one. So 2 out of 19. Why did I write 9? 2 out of 19 is where we're going to be at for this one. Okay, so that's kind of where we're going. Notice it was followed by, in this question, you're eating the chocolate. So the other one is not there anymore. Might sound redundant, but I just want to make sure I point out why the numbers are being reduced. All right, or this makes our probability a little bit better. We have to make sure there's no overlapping, right? So if I said probability of rolling an even and then rolling a 2, you don't want to count that one twice. So we're going to do that either in the bottom half or in the last page here. So everything you did in like a whole chapter of Algebra 1, we're going to do right now. All right, one card is drawn from a standard deck. What's the probability of drawing a 2? Probability of a 2. All right, so standard deck of cards is 52 cards, right? And there are 4 2s, plus there are 4 aces. All right, so we can deal with this any which way we want. What you do want to remember is that these reduce into 1/13 for each of them. Okay, but I want to give you the starting numbers because, you know, not too recently have kids played a whole bunch of cards because they have a lot of other things to do, like TikTok, they're on the Twitter, they're updating their MySpace page. You know what I'm saying? So, all right. Bag contains 4 green, 6 yellow. That's 10, 18. So I get 18. Drawn at random. Okay, so we want to get a blue or a green. How many are blue? So probability of blue. That was 8 plus, right? Because I'm dealing with or. So there's still 18. So this wasn't doing this in a row. This is I win if it's blue or green. I like these odds. Green, green, green was 4. All right, so we're going to be up to 12 out of 18. Maybe in the end here we'll reduce just to 2/3 instead of doing a reduction over and over and over again, because the numbers aren't getting too bad since we're just using addition. Multiplication, definitely want to hit them early because the numbers can grow very quickly. All right, yellow. Yellow was 6. We didn't deal with that one yet. The green was 4. All right, that's an 18, sorry. So it's 10 out of 18, so that's 5/9. It's probably getting a purple. Yeah, curveball, right? It says red, yellow, blue. It didn't say nothing about no purple. That's 0 out of 18 plus blue was 8 out of 18, so it's 8 out of 18. Okay, for all intents and purposes, you wouldn't have to write 0 out of 18. That's kind of silly. Okay, but make sure we're just kind of following along. Threw that one in there. And I like purple, so, you know, deal with it, I guess. All right, so here's what we're talking about. Probability of an even plus a probability of rolling maybe a 2. Well, remember, 2 is an even, so I have to take any overlap out of it. So A and B. Okay. So one card is drawn from a standard deck of cards. We're probably drawing a queen or a diamond. Okay, so how many are queens? 4 of them, right? 4 out of 52. Plus, and how many are diamonds? How many are diamonds? Do you remember playing cards? Okay, so that's 13 out of 52. Right, there's 4 suits, so if you take 52 divided by 4, you have 13. Now, here's the problem. There happens to be a queen of diamonds. How many are there? 1. There's only 1 queen of diamonds. All right, so we get these up here. We get 17. We're going to reduce that down, right? 17, 16, 16 out of 52. All right, and we're going to break that down. That's 4 out of 13. All right, so, you know, maybe you're not too up on cards, so just take your time with those as you need to. All right, red, and that's 16. Red cubes, red spheres. Okay, so 16 out of our grand total here, 29. Plus, right, because it's or, a cube. How many are cubes? First 2 are cubes, so that's 11 out of 29. But I have to take away how many are red cubes? 6. Okay, so that's going to get us our grand total 21 29ths. So we see our get our setup here. 29 spheres. How many are spheres? 18 of them. I don't know why I said it so weird like that. How many of them are green? Green, green, 13. How many of them are green spheres? Minus 8. All right, that'll get us to 23 29ths. All right, cube or a green. So cube, we'll set it up. Cubes, you're 11 out of 29 plus green. Green, you're 13 out of 29. Get rid of your Green cubes, which is 5 out of 29, gives you 19 out of 29. All right, one more. Thanks for hanging out. This has been kind of a longer video than we try and do. 29 red, there's 16 reds. There are 18 spheres. That's a lot. That's way too many. So there are red spheres. That's what we're going to take away is 10 of them. All right, making our final answer, 24 29ths. And again, these are all out of 29, so that's the upside of some of these ors, is we could try and pick what would be the best probability. All right, all right. Hope you enjoyed it. If I went too fast somewhere, please review it and email me any questions.